Hello everyone and welcome to lesson 25 of the Save My STEM Physics channel. Today we will be going through resolving vectors and forming a resultant vector from two components of that vector. So we'll just get straight into it. What is a resultant vector, or what is a vector in general? A vector is a quantity described by a direction and a magnitude. So we can take this velocity vector here, which has a magnitude, which is the length of the line, and has a direction, which is where the arrow is pointing. It doesn't just have to be a velocity. We could have a displacement like this, which would be s, and again, magnitude is the length, direction is the direction that the arrow faces. You could have a horizontal component of force. That would be a vector because it has a horizontal direction and it has a magnitude. But ignoring the horizontal force right now, we have two diagonal vectors here. And when working with these diagonal vectors, we find that things become just a tiny bit harder because we can't just straight up use the formulae that we already have. So what we must do is we must split or resolve this vector into two component vectors, a horizontal and a vertical vector, which forms a right angle triangle with the resultant vector. So I can label the horizontal component of v as v subscript x, and the vertical component as v subscript y. Alternatively, you could do v subscript h for horizontal and v for vertical. But I do it in terms of x and y because that's how we do it in maths. Now, one thing that you may already notice by the fact that it is a right angle triangle is we can take Pythagoras' theorem, which is v squared equals vx squared plus vy squared. You can also use trigonometry. So say that we have this angle here, theta, then v sine theta equals vy, because you may know SOHCAHTOA, SOH, so opposite is sine times hypotenuse, so the hypotenuse is v, and sine theta we already know. So sine theta v sine theta equals the vertical component, and using SOHCAHTOA again, we know that v cos theta equals v subscript x, which is the horizontal component. And this does not just apply to velocities. This also applies to displacements. This applies to forces. This applies to every vector quantity that you can think of. And the reason that we do this is because we can then plug respective values of horizontal and vertical components into something like a Suvat equation, which was the last lesson. So when we look at projectile motion, which is the motion of something like a ball in the air, that takes a parabolic path like this in this direction. And it may begin with, a resultant vector which looks something like that, which is tangent, which is an angle theta from the ground and has a vertical and horizontal component. Using that vertical component, we can figure out the amount of time that it's in the air, and using the horizontal component, we figure out the amount of distance that it travels. So we must split it into those two sections so that we can figure out exactly what those values are. So that's how we get two component vectors from a resultant vector, is using these two here. Similarly, to get a resultant vector from two component vectors, we are just going to use Pythagoras. So I will just note down here, for this one is comp for component into res, and these two are resultant into component. And that's resolving vectors, really. Um, there's nothing much to say about that. It's just a skill that you need to be able to have in order to tackle most of the mechanics questions, especially the calculations. Thank you very much for watching, and I'll see you all in the next one. Bye.